Thank you, Arno. That's a very kind introduction. I feel as if I don't know that person so well. Uh, there's a lot of things that we should all keep on learning every day. So it sounds accomplished, but I think I have a good day if I can say I've learned something today. So yeah, I wanted to introduce ISISPACE to those of you who don't know us. We are a Dutch company. The company was really founded in 2006, and I think why it's so appropriate that we talk about human capacity development and training is that our company was really founded not by professors, but by the students. So in 2006, a few students in the Netherlands from the Technical University of Delft decided they enjoyed their studies so much that they couldn't stop, and they wanted to start a company. The company was founded on the basis of the work these students did on the Delphi satellite program, and they really took a bold step at the time. It was not new space was not even a vision established at that time, and they really trusted themselves to fight and eke out a future for themselves, a future career for themselves. A good thing is that they really managed to do that. The company grew tremendously over the last years. Currently, we're at about 130 full-time employees. Nice thing is also that we are representing 25 nationalities, one of which is obviously South Africa. And in 2012, we established a South African subsidiary or a South African branch, and that I've been managing over this last time. So our company is virtually integrated. We try to service all parts of the satellite value chain. We've got well-established development labs, workshops, clean rooms, and control rooms. And we've done roughly 40 plus missions and more than 2,000 subsystems over this period. Also interesting is that we really find space and satellites as a global theme. And we've been collaborating with companies, with individuals around the world. This map is quite outdated. I'm quite sure that if I could get my colleagues in the Netherlands to help me, we can populate this map with quite a few more stars around the world. And to me personally, something which is special about our industry is that these stars don't just represent customers. They tend to represent friends and places in the world with special memories. So space is really a global economy, and I think the cube space or the small satellite, nanosatellite world is a very special part of that space ecosystem. So the reason the company was established, the reason we do what we do, was originally that we wanted to do satellites for different reasons. Originally, like I mentioned, we did a satellite program for, say, a training program from a university, but that led to more programs and more satellites. The satellites we did grew as well. The aspirations, the payloads, the complexity of the satellites also grew. And these days we offer quite a broad variety of missions, buses we call them, different satellite sizes. These things range from a very small satellites, I show up here in the left, 1U satellite, which is the smallest minimum size satellite we try to specialize in. Then we have slightly bigger 3Us, which can be used for maritime applications, like we also heard earlier from Professor Robert. And then they grow even more into 6U satellites. 6U satellites is a big focus area for us at the moment. Currently, we are working on quite a few signal intelligence programs where we say not only observe the Earth from a visual perspective, but also from radio emission perspective. That is very, very high growth area for us. Also, of course, IoT, Earth observation itself in terms of visual, hyperspectral, etc. And then the future, where we grow our buses towards, is the 12U, 16U satellites. These things are really capable satellites. They compete with much, much bigger satellites in the industry. Most of the big satellites I worked on earlier in my career can be fitted, or the functionality can be fitted in one of these 12U, 16U satellites quite easily. And they are really capable and complicated buses with vast capabilities. One big application that we see our company growing towards is also the area of methane observation, or the measurement and tracking of methane emissions. So that has got a big application in terms of fighting the problems we have with global warming or climate change around the world. So talking about the buses, we also offer products. So we have our company has got a small daughter company which sells both subsystems from ourselves and also third parties, also including several South African third parties, so third parties from around the world, including South African. And what we show on the website is really the hardware that we use for our own applications. Today, however, the focus is on training and the offerings that we can give you in terms of training and establishing human capacity development. So I wanted to highlight a few specific areas for training for capacity development. The first one was to look at a ground station. So one of the products we offer is our ground stations, both in VHF, UHF, and ISPAN. And from my own experience as well, early days at Stellenbosch, my very first satellite hardware that I was exposed to, or that I was responsible for, was not in the satellite at all. It was actually the ground station for the Sunset Stellenbosch University student satellite. So the ground station is really, after the satellite is launched, is one of the main things that actually remains on the ground, that remains visible. And as such, it gives an excellent focal point for a program. It also allows you to start working with satellites, to start listening to satellites, observing satellites, communicating with satellites, long before your own flight model satellite may be ready for launch, or may be built and ready for launch. So the reason a ground station is useful is then that it allows you to monitor existing satellites. Good examples of those are the NOAA APP weather satellites. Radio amateur satellites is also a useful way to start observing. And then there's a whole range of educational specific satellites. And a good example of those are the FunCube series of satellites. FunCube started as a single 1U satellite. These days, I think we count 5 or 6 various missions with FunCube transponders, FunCube based technology on, which is an excellent learning tool for students to see that the satellite is real and to actually experience the amazing fact that you can actually communicate with these things whizzing above your head in real life. So then the second training solution I wanted to talk about specifically was our generic engineering model. So we have offered this to several clients around the world. The generic engineering model, or the GEM for short, is an ideal way for a team to get an introduction into the hardware of the satellite. Typically, this is a team, or intended for a team, who actually wants down the line to build the flight model themselves. And as such, we didn't introduce the hardware separate from the flight hardware. We have the exact same hardware that is typically used in a typical satellite, and we give the teams who wants this hardware the opportunity to purchase an engineering model of this hardware. And it's EM versions of the real hardware. It's a real structure, it's a real OBC, it's a real radio, it's a real ADCS system, with slight simplifications, like, for instance, the antenna systems that you see there, just to allow the system to work well in a laboratory environment. Also, it runs on the flight software or the software framework. So it allows the team either to build up their own flight software, which is of course a major problem for satellite development, or it allows them to build or to use a framework, a pre-existing framework from our side, which is, say, almost a separate product that we can offer. In addition, besides the actual satellite hardware, this GEM also includes an opportunity to get familiar with the typical hardware that you use to build the satellite. So the mechanical ground support equipment, the electrical ground support equipment, and also the processes. So it's not good enough to only have the hardware, but you have to know how to use it. That processes is important. So I'll get you a few examples, but what we typically do, we tailor an offering towards the needs of a client. So if a client wants this hardware, we typically offer them or give them the opportunity to tailor the exact hardware that they're interested in with software or without software. And then we offer it to them together with a training course. So we give a short course of 1 to 2 weeks, more if needed, multiple short courses if needed, but allowing the user at the end to understand the various subsystems, to understand how it works together, and then to understand how they're going to use this to build up their flight model at the end of the day. Okay, so the next offering.
Smiling.
I just think I also have a bit of interference. So if there's an unmuted screen, then just mute it, please. Okay, so the GEM as such is slightly expensive because it includes all these various subsystems, like I mentioned. To get an idea of the price, you can look at the prices online available at UNISEC-Global. But we also have the newly developed training node, which is a scaled down version of this idea, but giving you a much smaller, much more compact, and also much more cost effective training solution. So this includes, say, a structure. It includes an electrical model of antenna, and then it includes a central node, which represents the power system, the computer system, and also the ISISPACE system. It allows us group to build up a very simple, basic 1U model satellite as a training kit, and it allows the students the opportunity to build up hardware and software on their own pace and with their own hardware. So the idea would be to take a simple off-the-shelf microcontroller, give one of these to each student, allow them to develop the software, and then bring that software that they've developed together with the application they've developed, plug it into the satellite model, the training node, and then they can firstly experience the way this works together, and secondly develop their own payload design for future use. The training node is not so much intended for say a flight model application, but it allows development and it allows first-hand experience with the system. So just going through a few examples, we delivered something like this for Brazil. Brazil is more of a theme. It's not only a single project, because you can also see that it grew up to 3 satellites, and there's even more ongoing at the moment. Originally, NCBR1 started with a 1U satellite, 2 ground stations, a 1U GEM. The satellite team in Brazil did their own payload development, and it resulted in a flight model launch in 2014. NCBR2 grew to a 2U satellite launched in 2019. Significantly, it also allowed them to develop their own training of their own hardware, their own payloads, and also their own ADCS. And then it grew into, say, bigger satellites. This is ETASat, which is a 6U satellite launched in 2018. Then Naive 1, this one is from the UAE, also a 1U satellite, also one of the FunCube satellites, very much a hands-on program, launched in, on PSLV in 2017. And interestingly enough, this team has grown on to much bigger things. They are now working on Mars. They are now on Mars orbiters working on landers for the moon, etc. The OneSat is for the Crown Prince Foundation in Jordan, also a FunCube product, and then also very much hands-on, allowing training course in AID, own ground station, images downloaded in Jordan, and voice recording of the Crown Prince, launched in 2018. Then Nalpa 2, this was for the Royal Thai Air Force. This has got several payloads on board, but main payload is a high-resolution imager. Also, we delivered several training courses and client ground station support. The nice thing about this project is that it really established the capability that the client was looking for over a few years, over a few missions, and it's getting to the point now where the client can operate the satellite on their own with minimum support from our engineering. GISTA, this was a traditional 3U gem with a tailored training course, again very much hands-on, focused on hands-on training. And in this case, it also had software development tools and example code to allow the team to test each and every part of the system on their own speed and at their own time. Just the program was slightly interrupted by COVID, but I expect it should pick up again. Then the last thing I wanted to focus on is just the fact that a satellite on the ground is not so useful. You don't want the orbit to be desk height or lab height. You actually want to get it into space. So the big thing, or the big training solution that turns the time where a satellite becomes practical is when it's actually launched. And a big thing for us is also then to offer launch services. This slide just gives you an example of how we've been involved in getting space, getting extra capacity for satellite launches. Typically, you have a launch vehicle. This is the example of the Vega. The upper part is the fairing, and inside the fairing, you have the upper stage. On top of the fairing, the upper stage, you typically then have the primary payload. And the excess capacity is these days being offered for CubeSat co-passengers, secondary passengers. So what we've developed there is the Boyer system. This one that you see in blue is the quad pack with space for 4 3U satellites or 12 1U satellites. If you have multiple of these things, say up to 10 or 15, you can go to a sequencer, which decides or determines when the several doors are opened and the satellites are ejected. And this is actually how we've launched several of the satellites that we've talked about today. For instance, from our side, we offer launch services, and this has grown tremendously over the past years from 4 satellites on Easy Launch 1 on PSLV in 2009, up to all the launches that you can see on your screen, including a world record case in 2017. We were responsible for 101 satellites on the PSLV. We've also been involved with the Falcon 9 launches, which is the transporter missions from SpaceX these days. And this has been a big learning curve for us as well, to be involved in this and to offer extra capacity to the client base, to our client base around the world. We had Falcon 9 in 2021. To 2022, we had one in the first quarter, and we actually expect to have another one at the end of the year. And yeah, like I said, this is something keeping us very busy, and it's an exciting part of the project of the industry to be involved in as well. That is what I wanted to share with you today. I want to thank you for the opportunity, and I also want to invite you to stay in touch, and please use my contact